sorting. And welcome back. Last time, we learned about sorting and how to use the NumPy sort function and method to arrange ndarrays. This time, we'll have a look at the argument sort function, comment on what separates the two, and explain how it can be useful when manipulating arrays of data. Let's begin by importing and displaying the dataset. Perfect. Before we reveal what argsort does, let's call it and plug in the newly imported data as an input. We write np.argsort, and within the parentheses, we add the lending company data numeric. We get an array, which includes the values from 0 to 5 on every row and nothing else. This is because instead of sorting the values themselves, the function returns the indices that would sort this array. For the first row, for example, the way we read this is the following. The value with index 1 is the smallest, followed by the value with index 2, and then the one with index 0. The rest remain unchanged. If we examine the original array displayed above, the values for those indices are 40, 365, and then 2000, followed by the last three columns in the order they are currently at. Another way to verify this is to call the sort function into a new cell. Looking at the first row, we see that if we take the values of the original dataset and arrange them according to the output of the argument sort function, we'd get the sorted array. The same is true for the second, third, and all subsequent rows, but we won't examine each one individually. Fantastic! Just like with np_sort, we can call the function over a given axis. In a new cell, copy the default argsort code and set axis equal to 0. Each column of the output array contains the order of the indices which would sort that column. Therefore, if we look at the last one, it states that the entry with index 482 should be the lowest overall. Let's call that element and see if that's true. The output is -350. To verify this is the lowest value, we can go back to the previous cell where we called the sort function and specify the axis argument accordingly. The output confirms -350 is the lowest value in the last column, so argsort works perfectly. All right. As was the case with sort, we can use argument sort to arrange individual rows or columns. For example, we can arrange the values of the first column and get their indices. Even though the 1D array output doesn't seem spectacular on its own, it can be extremely useful. We can take this order to rearrange all the rows based on their values in the first column. We do so by going to a new cell and setting the dataset variable equal to itself, given a certain condition. Then, we'll specify this condition inside square brackets, where we'll paste the argument sort for the first column. All the rows should remain intact and just be arranged in ascending order, based on the values stored in the first position of every row. To see if that's the case, we'll display the dataset variable. We clearly notice that the values in the first column are arranged appropriately, but the same can't be said about the rest. So we successfully rearranged all the rows based on the values in the first position. This can be extremely useful when each row of a dataset contains information about a specific client, or date, since we want to keep this information intact. For example, if we're analyzing a portfolio of stocks, each row in the dataset can represent the stock of a different company. Therefore, if we decide to sort the dataset by the values in each column, we can do that without losing track of the numbers that belong to each row, which means each stock. Great job! So, just like np_sort, argsort has a corresponding method of the same name. However, this one works the same way and doesn't overwrite the original array. To test the argsort method, we first write lending company data numeric dot argsort, and in the parentheses, we set the axis to 0. After we run the cell, we get another array with all the index values that will arrange each column. However, we can't really tell if this has altered the data in any way, so in the next cell, we can display the dataset variable. If we look at the lower 3 rows, we can immediately notice that the columns aren't arranged. Hence, the method doesn't overwrite the original array, and we can use it and the function interchangeably. Splendid work! It might not be very convenient to remember by heart which NumPy functions have methods as counterparts that work in the same way, and which overwrite the original array. Nevertheless, we know that NumPy functions have simply been programmed like that. So let's stay positive and rely on practice to learn how the various methods work. After going over sort and its corresponding argument function, argsort, we're ready to move past arranging. However, we're not finished with argument functions. In the next lecture, we'll examine the arg where function and discuss its value. Thanks for watching.